I am Anil Kumar. Welcome to my series on mathematics. We are learning some basic skills. One of them, which is most important, is Pythagorean theorem. We understand Pythagorean theorem right from the middle school, and till the high school, we are actually solving many difficult questions with Pythagorean theorem as the base. So it's a good idea to understand this theorem. We'll begin with understanding what Pythagorean theorem is. We'll take a proof of the Pythagorean theorem, solve few triangles, and then understand that converse is also true. That is, if the sides are related as a square plus b square equals to c square, then it will form a right triangle. We'll take up example based on circle with triangle, 3D applications, and then examination style practice. Now, to begin with, whenever we use Pythagorean theorem, one thing which is common is right angle, correct? So always we have to look for a triangle, and in a triangle, we have to look that there has to be a right angle. Only then the Pythagorean theorem is or can be applied, right? So this particular side here, which is the longest side, is called the hypotenuse. And the other two sides, we refer to them as legs. Generally, we could just give any name here, let's say A and B, and let's say if this is C, then the relation is that A square plus B square equals to C square. That is what Pythagorean theorem is. Perfect. So I just mentioned here that a right triangle has right angle. This is the right angle, 90 degrees, as one of its angle. The side opposite to the right angle is called the hypotenuse. This particular side, which is also the longest side, is the hypotenuse, and the other two sides are called legs. Hypotenuse is the longest side in the right triangle. Correct? Now, let's try to understand Pythagorean theorem itself. So if I take a right triangle, which I'm trying to show here, this is my right triangle, the inside one, right? So if you take a right triangle, which is shown here, in that case, you will notice that this is your right angle at present. So in any right triangle, the relation c square, the hypotenuse square, which in this case is the side opposite to the right angle, is sum of a square and b square, the legs, right? So that is what the Pythagorean theorem is. Right? You can actually visualize it as the sum of squares. Now, what is a square? A square. A square will be the area of this particular square, correct? So this area will be a square, right? So this is a square. The area of the other square on the side of B will be B square. And on the side of hypotenuse, we'll have the third longest side, hypotenuse, whose area will be C square. So these areas are actually related. So a square plus b square is equal to c square. So that is what Pythagorean theorem is. So in a right triangle with hypotenuse c and the smaller sides as a and b, c square is equal to a square plus b square, correct? You can visualize a right triangle with squares on each side. Area of the square is square of its side lengths. The area of the square of the hypotenuse is equal to the sum of the areas of the squares of the legs. That is how you could actually write it, right? Let's try to prove Pythagorean theorem. So what we have done here is that we have taken a square. So that is the big square which we are talking about. Now in this square, we have divided the length as in two particular parts. So we've just taken points on the square so that we have this length as combination of a plus b, right? So this length is b plus a, right? Do you see that? Here this length is a plus b. So square has all equal sides, and this length here is also a plus b, and the length here is also a plus b. So we have a square, the outside square, with lengths of a plus b. Now if I join these 2 points as shown here, we get a square inside, and the sides of that square has been taken as c, right? Has been taken as c. Now to prove the Pythagorean theorem, which is a square plus b square is c square, we can look into any particular triangle for that matter. What we will do here is that we'll equate the areas, right? So as you can clearly see, what is the area of big triangle? So area of big triangle is, since the sides are a plus b, so it'll be a plus b whole square. So that is what the area of big triangle is, right? That is one part. So that is what I've taken on the left side right here. So that is the area of the big triangle. The other way to look into this particular area is that it is also equal to area of four small triangles. As you can see, these are the four small triangles, correct? And area of a triangle is half base into height. So you can also say it is area of four small triangles plus area of small square. Perfect. So it is also this combination. So we could equate this, and that's what we have done. 4 times half of base times height, that is base times height, that becomes area of one triangle. When you multiply this by 4, you get area of all the 4 small triangles, plus c square, which is the area of the center part. So that is also the area of the big triangle. So both have now been equated. Now you can expand a plus b whole square, which is equal to a square plus b square plus 2ab. You could write it in any way. And here, when you cancel 2 with 4, you get 2ab, right? So you could cancel this and 2 times. So this is 2ab plus c square. And now 2ab and 2ab, they get cancelled, and you get a square plus b square equals to c square. And that is what Pythagorean theorem is. Do you see that? So this is one of the best or the simplest proof for Pythagorean theorem. Perfect? Okay. So we understand that in any right triangle, sum of squares of the legs is equal to the square of the length of the hypotenuse. Perfect? Knowing this, let's try to solve some triangles as it has huge applications. So now I'd like you to pause the video, answer this particular question, and then check with my solution. In our example number 1, where we have 3 triangles, I will say find missing side of the right triangle. So missing side has been termed as x. Now that is the missing side for these triangles. Now I would like you to actually copy these questions and solve them. So we know that in any right triangle, Pythagorean theorem is always true, which is that if I have two legs as a square plus b square, it could be related to the hypotenuse as equal to c square, correct? So where in our triangle, we are looking at something like this. The sides are A, B, and C, correct? Longest side is hypotenuse. So that is the basic relation which we are trying to follow. Okay, so in the very first triangle, the unknown side is one of the legs, correct? So what we can do here is we can write sum of these two squares as equal to the hypotenuse square and then solve for x. That is what we have done, correct? So in the first case, sum of these two, which is x square plus 3 square, is equal to 5 square. Now we need to find what x square is. 5 square is 25, 3 square is 9. Taking 25 minus 9 on the right side, we know x square is 16. So that gives you x value as square root of 16, which is 4. We have to always take positive values for length, right? The next example is kind of similar, where the sides are different. Hypotenuse is again given to us, so that is 13 square. And the other two small sides are x square and 5 square. You can actually solve this and get your answer as 12. Now the third example has two triangles, right? So it's a combination of triangles. So see, so we have a combination of triangles. Now, how will you do this question? Well, we'll begin with the triangle where most of the sides are given to us. That's the right angle. Now this is the isosceles triangle which is given to us. So we know one of the sides is 1. So the other side should also be 1. So we have AD and DC as 1. And therefore, AC will be what? 1 square plus 1 square square root. And therefore, that should be square root of 2. So we can find that AC is equal to square root of 2. Once you know that AC is square root of 2, you can again apply the Pythagorean theorem second time in this question and find the value of x. X this time is the hypotenuse. So 4 square plus square root 2 square is x square, and you can solve this to get your answer. So you can look into the solution once again. However, I think you have understood. So we began with the small triangle ADC, which is the right isosceles triangle, where the sides are 1 and 1. So AC square is sum of these two, and AC will be square root of 2, as we figured it out. X square is equal to 4 square plus square root 2 square, which is 16 plus 2 or 18, and x is square root of 18. Now when you get to square root of 18, the exact answer will be, in radicals, we can write 18 as 9 times 2. And square root of 9 is 3. So we write 3 outside and 2 inside the radical side. So we get the side length as 3 square root 2. Perfect. So that is how you're going to solve it. Now, let's talk about Pythagorean triples now. In our previous examples, we did see some numbers which are whole numbers and which were sides of the triangle. So now we will see how to generate these numbers. That is very interesting. So what is a Pythagorean triple? A set of natural numbers like a, b, and c, three natural numbers, are called Pythagorean triple if a square plus b square equals to c square is true. So out of these three numbers, sum of two squares should be equal to the square of the third. Then we call it a Pythagorean triple. And as we have seen, 3, 4, 5 is one of the most common examples. The others could be as mentioned here, but there could be many more examples, right? Now here is students' activity for you. What you need to do is to generate triples, right? So the whole exercise here is to generate Pythagorean triples. I've given you a formula and made a table so that you could easily generate it. Now the formula is to generate a list of triples. What they said, the formula is that one number could be 2n plus 1, the second number is 2n square plus 2n, and third number is one more than the second number. Okay, so here n is all natural numbers, right? So you can say n is non-negative integer, okay, or a positive integer. But writing n as a natural number is better because there's no point having n as 0, right? Okay, because the side length cannot be 0. It has to be greater than 0. Perfect. So make a table as shown here. N is number 1, 2, 3, 4, and then make 3 columns. Calculate the values, fill this up to generate your own triples. Is that clear to you? So let this be an exercise for you. Perfect. And it's a good idea to remember some triples. Now it's also important to understand that if one of the triple is 3, 4, 5, then multiplying by 2 will give us 6, 8, and 10. That is also a triple, right? Multiplying by 3 will be 9, 12, and 15. That is also a triple. Multiplying by 4 will be 12, 16, and 20. That is also a triple. So once you generate a triple, it could be multiplied, and then you could generate many other triples from the same. Okay, and with the second set, you can get even more number of triples. So if I write a value of 2 here, in that case 2 times 2 plus 1, which is what? 4 plus 1 is 5, right? Now here we get 2 square, that means 2 times 2 square is 4, plus 2 times 2, right? So 4 times 2 is 8, and 8 plus 4 is 12, right? So this is equal to 12. And this is actually one more, so that will give you 13. So the next triple which I have got here is 5, 12, and 13. Correct? You can verify that this actually is a triple, right? So it will represent a right triangle with sides of 5, 12, and 13. Right? You could verify that. Since you know that in this particular case, 5 square plus 12 square will be equal to 13 square, right? This is 25 plus 144, and that is 169. So we could actually verify our result. And likewise, you can actually fill this up and verify your result. Clear? Now, it is also very important to understand the converse of a Pythagorean theorem. Now, the converse states that if the sides are so related that a square plus b square is equal to c square, then the triangle formed will be a right triangle. Correct? So let me repeat this. If a triangle has side lengths of a, b, and c units, and a square plus b square equals to c square, then the triangle formed will be a right triangle. So that converse is always true. Now here is another question for you. So it is in the form of an example. So the question is, which of the following set of side lengths represent a right triangle? 4 choices are given to you. You can actually pause the video and answer this particular question. Perfect. Okay. So the way to do it is that if you're looking into the numbers, let us say 1, 2, and 3, then what is 1 square plus 2 square equals to? Well, it is 1 plus 4, which is 5, but definitely it is not equal to 3 square. So that really doesn't work, right? Similarly, for the second one, we could do 2 square plus 3 square, which is 4 plus 9, which is 13, and that is not equal to 4 square, right? Since you know 4 square is 16. The third one is 3 square plus 4 square, which is 9 plus 16, which is 25, which is definitely equal to 5 square, and therefore that is the right option. Correct? So that is how you could do it, and therefore option C is the correct option. That is how you'll do it. Perfect. Now let's take some application questions. Here is a very interesting question, which is also a real life situation. The question here is, Anil drives at an average speed of 60 kilometers per hour to the office. If he drives north for an hour and then east for 90 minutes, find the shortest distance of his office from home. So that's the question for you. Now, in real terms, what you should do is you should actually sketch the diagram. So let us say he drives north, right? So he drives north, let's say. Let me make it here. So he drives north for an hour, right? And then east for 90 minutes. Now, the shortest distance will be the distance from home to office, kind of like this. You get the idea, right? So that is how you're going to draw. Now, this right here, since you are going north and then you go east, definitely it is going to be a right triangle, right? So that is your home. Now, we can actually find the length of the shortest distance, which is the hypotenuse, right? This is your hypotenuse, using Pythagorean theorem. Perfect. Also remember that distance, speed, and time are related with this particular triangle. So in this triangle, in short to remember, distance d is the product of speed and time. Correct? That is important to understand. So to solve this question, we also notice that the speed is given in 60 kilometers per hour. If he drives north for an hour, that is okay. East for 90 minutes. So that means we are mixing up the units. Minutes and hours. Do you see that? So we have to convert to one particular unit. So good idea is to convert minutes to hours. And that is a very good strategy while solving questions. So the first step here is to convert 90 minutes to hours. How are you going to do it? Well, we know that there are in 1 hour how many minutes? 60 minutes, correct? That is the relation. So now we have 90 minutes here. To convert to hours, we have to cancel the minutes. We know in 1 hour there are 60 minutes. So write 1 hour over 60 minutes, and clearly the minutes and minutes cancel. What remains is an hour. And when you divide 90 by 60, you get 1.5 hours. Is that clear to you? Perfect. So we get 1.5 hours to travel in the east direction. Now, the relation between distance, speed, and time is, as I was saying, distance equals to speed into time, right? So that is the relation. So let's find the distance traveled north first. So the distance traveled north will be 60 kilometers per hour times 1 hour, which gives us 60 kilometers. Now the distance traveled towards east, let me write this is east, right? Is the speed is same, 60 kilometers per hour. However, the time is 1.5 hours. So that gives us 90 kilometers. So we have this distance as 90, this distance as 60. To find the hypotenuse, we'll apply the Pythagorean theorem. So here is Pythagorean theorem in short, right? So basically, you will add one step here. So we'll say that the distance d is equal to, rather we can write d square is 60 square plus 90 square, correct? So d will be square root, right? So d will be square root of 60 square plus 90 square, correct? So that is what is written here. Use calculator and round your answer. So you get 108.2 kilometers. Is that correct? So that is how you would actually solve such a word problem. So it requires a couple of steps. One of them is to convert the units. Second, to remember distances, speed into time. Perfect. And then apply the Pythagorean theorem to get your answer. Perfect. Let's move on and take the next example now. Now that is an example with the 3D applications. You can see what a wide variety of questions can be solved using Pythagorean theorem, right? So the question here is, the Great Pyramid in Giza in Egypt has a square base with side 220-meter long. The distance from the top of the pyramid to each corner of the base is 233 meters. Find the height of the pyramid. So we are given a square base, right? So this base is square. That is important to understand. Square means that the sides are at right angles. So this is at right angles. That is kind of important, right? We know the lengths of these sides are 220 meters, and from top to the edge, this is your edge, right? So the edge here is, as written, 233 meters, correct? Now we need to find the height. So height basically is E to O. That is the height which we are interested in finding. How will you find it? What is the strategy to find it, right? So let's think about it. So first thing is, we need to find the diagonal of the square base itself. So that is our first step. So ABCD is the base of the pyramid, and that is square. The triangle ABC is right triangle, as you can see, since that is a square, right? So the triangle ACB, we can find the diagonal using the Pythagorean theorem, right? So we can use Pythagorean theorem to find A to C, right? So the first step is to find A to C. So that is our first step, correct? So let's find using Pythagorean theorem. AC square is AB square plus BC square, right? So this is AB, that is BC. So that gives you a relation for AC square. Plug in the values. AB is given to us as 220, BC is also 220. Well, when there are same sides, you could always write it easily as 220 square root 2. Perfect. So that is how you get it. Now, square root 2, we get this with square root. Okay, so here's a typing error. Let me just remove this. AC is, oh, sorry, this is okay. This is okay. So AC is 220 square root 2. This is AC square is that much. Use calculator. However, you could go from here to there directly, since you should understand that in any triangle, isosceles triangle, let's take a special case, okay? If the sides are same, A and A, for a right triangle, then this side will be what? A square plus A square square root, correct? Which is 2A square square root. So A square comes out as A, and you get square root 2 as your answer. So in this case, you can see 220 square root 2 is your answer for the diagonal, right? So that's an easy calculation. Now, AO is half of AC. So we do half of that to get the result as 110 square root 2. Now, once we know the diagonal, we are now interested in the height. So basically, we want to now find this particular height, correct? So our figure is kind of like this. So let me redraw this particular figure with that is A, and this is the center. We're calling this as O, and this is E, right? So we found that this is height, that is at right angles. This particular side here is 110 square root 2, and the other side is given to us as 233. So height is the smaller leg, so it is difference of squares, right? So this is what we need to figure out. So that is difference of squares. So we can find AE square as the hypotenuse square, EO square is the hypotenuse square, AE square minus the AO square, correct? So it is difference. So we find the height using this particular formula, substitute the values and calculate your result. Is that clear? So that is how you should be actually solving this particular question, right? So I hope you can see it now perfectly. Now let's move on to examination style questions. Now here I have 4 questions for you, right? So these are actually based on Pythagorean theorem. In many test papers, we have very difficult questions, and some of them involves a lot of geometry and some concepts which relate to circles. So here are the examples. I'd like you to pause the video at this stage, copy these questions and try to solve them out. Question number 1. AC is the diameter of the circle O in the triangle ABC. So here you see the triangle ABC. AC is also the diameter of the circle. Do you understand? So it is a semicircle. Find the radius of the circle if AB is 12 and BC is 9. So we are given the dimensions, and here we are saying this is 12 and that one is 9. Is that clear? Now we need to find R. R is half of the diameter. That's the question for you. Okay. Question number 2. Find the area of shaded region DEB, which is shaded in green here, in the rectangle ABCD as shown. So we are given the dimensions 7 by 3. And this is what area you need to find out. And D to E is given to us as 5, correct? Question number 3 is, find tangent length AP, that is this particular length, this is the tangent, from point 13, 0 to the circle x square plus y square equals to 25. So that's the circle, and let us say this is the origin O. Then you know that if I connect these 2 points, then we have a right angle at A, correct? We need to find the length A to P. That is what you need to find. So that's a very tricky question. So the hint is, think like this. When you draw this circle, it will be on the axis, correct? So this will be kind of like this. So that is a good hint for you. So use this particular hint. This is your XY axis, right? And then it'll be easier for you to find. Okay. Question number 4 is a very difficult question. It says area of a square PQRS is 625 centimeters square. Okay, so this square PQRS is 625 squares, and area of the rhombus QRTU is 500. So this is 500, right? Find the area of shaded region in centimeters square. So you have to find the area of this shaded region. 4 choices are given to you. Okay, so let's first understand the strategy, and then we are going to provide the solutions to all these questions. The very first question here is, AC is the diameter of the circle O in the triangle ABC. So we have this big triangle here where AC is also the base of the triangle and the diameter of the circle. Find the radius of the circle if AB is 12 centimeters and BC is 9 centimeters. Now the key to this solution is that in a semicircle you always get a right triangle. So at B we have a right triangle, correct? And therefore we can find AC. So we know that AC square is actually equal to 12 square plus 9 square, correct? So we get AC from here, right? And then radius is equal to half of AC. So diameter half is radius. That should give you the answer of this particular question, correct? In question number 2, the area of the shaded region DEB is what you need to find, right? Now, the area of the whole rectangle is 7 times 3, right? So we can say area of the rectangle minus area of this triangle, which is a small triangle, right? Well, and these 2 triangles. So minus area of these 2 triangles is equals to area of triangle BED. Does make sense to you, right? So we have to, full area is 7 times 3, right? We know this area is 7 times 3, which is 21. And from this area, we have to take away these 2 areas. And then you're left with the area of DB. How will you find it? Well, it is a rectangle. That means this side is also 3. The hypotenuse is 5. So we have this side as equal to what? It is 5 square minus 3 square square root, which is equal to 4. So you can find this side as 4, and the area will be 4 times 3 divided by 2, which is 6. Here it is 7 times 3 divided by 2, 21 half, right? And 21 is the whole area. So I think you got the idea. Perfect. apply this strategy to solve. Third question here is, again, we have a right triangle, since we know that the tangent and the radius are always at the right triangle. Now, trick here is that point P is 13, 0. That means this is at point 13 and this is at 0. So that means OP is equal to 13 for us. We know that OA is the radius and radius is 5, correct? Because 25 is 5 square. So this is 5 and that is 13. So that should be triple, right? You remember? So we know that AP should be equal to square root of 13 squared, because that is the longest side, minus 5 squared, right? Which will give you 12. So that is how you're going to find that solution. Is that clear? The last question, question number 4 is, area of square PQRS is given to us as 625. So we should find what is QR. So from here, we know that QR is square root of 625. So side length is actually 25, correct? So this is 25. So each side is 25 for you, correct? So all these sides are 25 each. Is that clear to you? Now, for the rhombus, the area is 500 centimeters square. Now, how does that help you? Well, for the rhombus, what is the area? It is, see, base into height times 2, right? So, or you can say base into height, right? So, it is basically a combination of two triangles, right? So, think like this. If our height is h, in that case, base into height is 500. So we can say 25h equals to 500. So h is equals to 500 by 25. That gives you what? So 25 goes 2 times, 50, and then 0, 20. So we know this particular height is 20. So that means this is 20, correct? So 20 means 25 was all, this is 5. Now I think you got the idea how to find it. So we know this area is 25 times 5, and this is a triangle which has 20 as the height, and how much is this length? This length is similar to, so you can figure this out, say, from the symmetry. We can find the length using Pythagorean theorem. Do you understand? So this length will be, since we know the sides are 25 and 20, therefore this side will be how much? So that side will be square root of 25 square minus 20 square. Correct? So that will give you this particular length, and then you should be in a position to find it. So I hope the hints are good enough, right? I'll give you some more time to now solve this question with all these hints, right? So what I provided you with just now is some hints, correct? So I hope they work in your favor. So you can actually pause the video and then solve them. Well, quickly. Now let's look into the solutions which we have already discussed. The very first one is actually not so difficult. We figured out that always in a semicircle we have a right triangle, and therefore the two sides are related with the third. We can use the Pythagorean theorem, and we know here that the longest side is the diameter itself, and AC square is AB square plus BC square. Substituting 12 and 9 and square rooting, we get 15. The radius is half of that, correct? So half of 15 is 7.5. That becomes the radius for us, correct? Right. Now let's move on and take the next example. So next example, as I was saying, is related to the area of the rectangle. Area of the rectangle, which is 7 times 3, right? So I've written here 7 times 3, the area of rectangle. From this area, I have to take away the area of this particular triangle, which is half of 7 times 3, and also this particular triangle, correct? whose sides are 3 and this is 4 since the hypotenuse is 5. So 12 half is 6. Once you do that, you get 4.5 as your area of the shaded region. So that becomes your answer in unit squares. Clear? Now the tangent question, which seems to be very difficult, let's look into this now. So here it says, as we understand, that the sides are basically, okay, right. So in this particular case, what we notice is that if I join point A with the center O, in that case we do have a right angle, right? We also said that the circle is x square plus y square equals 25, which is 5 square, right? So that means radius is equal to 5. So this is 5 for us. On the other side, O to P is 13 for us since this is at the axis, correct? So you could always draw the axis here as x and y. And now it's very simple. We have a right triangle where one side has 5, the other side has 13, and so we know what AP is. Is that clear to you? So that is what we've done here. We know 5 square plus AP square is 13 square. So we isolated AP and got this as square root of 144 and came to 12. So that's a triple. You remember, right? So a triple which is 5, 12, 13. Okay. So that is how we do it. Now, since I provided you with this answer, here is a question for you. So I'd like you to copy this particular question, practice question. Find the perimeter of the quadrilateral OAPB if PA and PB are tangents from the point P 12, 0 to the circle O, defined by the equation x square plus y square is 81. So we have changed the equation of the circle, and that is the quadrilateral which we're trying to figure out. So now you need to find the perimeter of the quadrilateral OAPB, right? And we're given a new equation that basically means 9 square, right? So radius in this case is 9, and then you can solve it. Perfect. The last question is kind of tricky. So let's go through this question once again. We have a particular square. So the question is, area of the square is 625. That helps to find the side lengths, correct? So here, this will give you the side length, right? Area of rhombus is 500, but we know one side is common. And when you calculate, this side is 25. And that helps you to find the height. Is that clear to you? Correct? Once you find the height, you could actually divide like this, and we'll call this point as, let's say, V. We know this particular height. And since 25 is square root of 625 is the total height, we know the missing dimensions. And that should help us, right? So let's look into the proof right here, which is the area of the square is 625. Side length will be square root of 625, which is 25 centimeters. Rhombus side length, one of the side length for rhombus is 25. That means all are 25, correct? Now, we need to find the area. We know the area. We need to find this particular height. So base into height is the area, right? So base into height is area of rhombus. So from here we found what height is. Height is 20 for us, right? So we got this height of 20. So we're left with 5 on the other side, right? Diagram is not to the scale. Now this 20 helps us in two ways. It also helps to find this particular length and thereby the triangle area. Perfect. So let's continue. So let V be the point on Q P so that TV, we have this V point here. So we have this particular triangle. Okay. Now in triangle VTQ, it is a right angle triangle. And here VT, which is this particular length, it is a leg, which is equal to 25 square minus 20 square, which you can calculate as 15. So this is 15. Now you can find the area of the small triangle, add the area with the rectangle, you have the area of the shaded region. Is that correct? So here is your final solution. Area of the shaded region is area of the rectangle plus area of the triangle. Rectangle is, as you know, the small rectangle, 25 times 5, and triangle is half, 20 times 15. You get your answer as 275, which is option C for you. Perfect. So with this, we have solved all the questions, and I hope we have understood a lot. So we covered in this video the basic concepts about Pythagorean theorem. How do we solve some triangles using Pythagorean theorem, right? Even how to prove the Pythagorean theorem, how to solve the triangles, and then we had some examples, even producing the triples. Converse is also true, working with the distance question, and we're finding the height of a pyramid, and then we did examination style questions. So I hope you find it interesting and useful. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'll be great. Thanks for your time and all the best.